So we have been doing a whole lot of work with equations and inequalities, and now we've learned everything in Unit 1. So today we're taking a practice quiz. Now keep in mind, this counts as notes. Anything you have written down counts as notes. You can use notes when you take quizzes. So write down the answers, write down your work, take any notes that you find helpful. You'll be able to use this whenever you take this quiz. I'm just going to label my paper. This will count as your exit ticket for today. It's not due until Friday. You will just turn this in when you take your quiz with your quiz, and I'll just count that as your exit ticket. I'm not grading it for accuracy. I'm just grading to see that you completed it. So if you fill it out with us, it's free points. So today is day 5, and it is Monday, March. Angel, we are doing a practice quiz if you want to grab one once you're settled. It's Monday, March 31st. Almost April. Crazy. Let me mark that you're here before I forget. Perfect. All right. So on our first page here, the first 4 questions are just equations that we're solving. You have a few 2-step equations, a few multi-step. Let's just start with number 1. 5n minus 3 equals 12. When I'm solving an equation, I'm thinking about operations. I have multiplication and division, I have addition and subtraction. Which operation should we be getting rid of first? Addition and subtraction. So I'm going to make a little note over here just to help me remember as I solve other problems. First, addition and subtraction, then multiplication and division. So that's the order we go in. So we have 5 times n, that's multiplication. We have minus 3, that's subtraction. Which one should we do first? The minus 3. So to get rid of that, we do the opposite. We're going to add 3 to both sides. Okay. So what happens to our 3's? They cancel. They're gone. And what do I do next?
Bring down the 5n.
Bring down the 5n. Equals 15. Good. All right. 5n equals 15. Perfect. Now we'll divide both sides by 5. Beautiful. 5's cancel. I get n equals, now let's check, 15 divided by 5. What's that? 3. Perfect. And that's our answer, so we circle it. Please circle your answers. That makes things much easier on me when I'm grading a million papers. You're writing a lot of numbers, so circling the one that you want me to grade is helpful. Any questions on number 1? Okay, let's look at number 2. This one's a little trickier. We have variables on both sides of our equation. What's something we could do first? Yeah, we could do that, absolutely. Let's subtract 2 from both sides. Now, since I've got a lot of stuff over here, am I subtracting 2 from...
51.
Good, yes. Minus 2 over here.
The 2 cancel out, bring down the 4n. Equals. 3n plus 49.
Perfect. Okay, so now we're here. And what should we do next?
We can add 3n to the 14.
Yes, here's where it gets tricky. We need to make sure that we have our variables all on the same side. So we're going to add 3n to both sides. Yes, that way it cancels over here. No more n's on this side. 7n equals 49. Perfect. Divide by 7. N equals 7. That is our answer. Awesome. Okay, do we have any questions about number 2? Okay, great.
How are we breaking down to
Sure. Okay, so let's go back to our very first step. We subtracted 2 from both sides. So on this step, do we understand what's going on here? Okay, so let's just start from the very get-go. Whenever we are solving an equation, we're trying to find what number can I replace in my variable with to make this problem true. And in order to figure that out, we have to do some rearranging. So as we rearrange all of these things, our goal is to get n equals a number. So, first of all, I could think to myself, well, I have a plus 2 over here, and I want to get rid of it, because that is keeping n from being by itself. So anytime we want to get rid of something, we're going to do the opposite of whatever operation it says. So a good note also to make is our inverse operations chart. So I'm going to just write that up here as well. Inverse operations. So just as a reminder, addition, what's the opposite of addition? Subtraction. And multiplication, what's the opposite of that? Yeah, division. Perfect. So those are the 4 main operations we are thinking about at this point. So, starting back from the very beginning, I'm going to actually just rewrite the problem so that we're not looking ahead. 4n plus 2 equals negative 3n plus 51. Okay. So, if our goal is to get n by itself is equal to a number, if we're looking at this side of our equation, I see we've got that plus 2 that we're going to want to move. So to move it, we do the opposite and subtract 2. So you're following me to this point so far?
Yes.
Okay, perfect. Now, how comfortable are you with knowing where else I'm subtracting to? It would be the 51. Now, do you know why it's the 51?
Because they don't have no n.
Yes, perfect, perfect. I can't subtract 2 from n's because I'm not, yeah, it's got to be like terms. So our 2's will cancel out. And then at each step, we just rewrite everything that didn't cancel. So we have 4n that we'll write below. The 2's are gone, so we skip over that. We have an equal sign that we're going to write below. Now we have negative 3n or minus 3n. And now we do a math problem. We have 51 minus 2. And what does that give us? 49. So that is where we're getting the 49. And we just bring that down. So now we're here. And I'll let you get, I see you're still writing, I'll give you a second. You just tell me when you're ready for the next step. Perfect. Okay, so now I'm still thinking about my end goal of having all of the n's or all of the variables on one side of the problem and all the non-variables on the other. So we normally think of a number next to a variable as its multiplication. You know, 4n means 4 times n. Negative 3n is negative 3 times n. But we can also think of these as entire items in a way. where I can combine these numbers because they both have n attached by adding and subtracting. So if I wanted to get these n's over here, how would I do that? Yes, with the plus. So again, we're doing the opposite of whatever sign is written. So minus 3n, we'll do plus 3n. And where else would I add 3n? Under the 4n, good. Okay. And then what happens to my minus 3n and plus 3n? Yeah, these are going to cancel out. Let me use a different color. I feel like I'm looking on the board and I can't even see what I'm writing. Sorry, guys. Let me just kind of trace over this real quick. Okay, so we just added 3n to both sides. And whenever I use my inverse operations, what happens to these 3n's? They cancel. We cross them out. And now anything that didn't cancel, we bring it down, or we do the math problem that we have. So we'll start from left to right. Over here, I've got 4n plus 3n, and that becomes 7n. Good. Then I have my equal sign. I'll bring that down. My 3n's canceled. I don't need them. What else comes down? Yeah, 49. Yeah, we'll just bring down that number, 49. And I like to think of a plus sign. It's kind of like an and sign. It's saying I had negative 3n and 49. Since negative 3n is gone, I really don't need the plus sign anymore because it's just 49. So now we have 7n equals 49, or 7 times n equals 49. So we only have one thing left to get rid of to get to n equals a number, and that's this 7, which is being multiplied. So this is where we use our inverse operation. Since we have 7 times n, or n times 7, we want to do the opposite of times, which is dividing, yes. So we will divide by 7 on both sides. Okay. And what happens to my 7s? They cross out, they're canceled. So we have n left all by itself. Bring down the equal sign. And our last step is to just do 49 divided by 7, which gives us 7. And that is our answer. It's a long process, but we can do it. We can do it. Okay. Any other questions on that one? Awesome. Okay, let's look at number 3. Number 3 is another slightly special case. Why is number 3 special? Say it again. It is kind of written in a different way. Yeah, we got a fraction going on here. Normally we do addition and subtraction first to get rid of it, but can I subtract 5 if it's in a fraction? No. I cannot. I can't do that until I get rid of this 3. So a fraction is just a division problem, right? It's just n plus 5 divided by 3. How do we get rid of divided by 3? Multiply. So we're going to do times 3 on both sides. And what happens here? Good. My 3's cancel. N plus 5 equals 36. Perfect. Yes, then all that's left to do is to subtract the 5 from both sides. 5's will cancel. N equals 31. Perfect. Okay. Good deal. Any questions on number 3? Okay, let's look at number 4 then. What's going on in number 4? Yeah, we got to distribute this 6 before we can solve it. So, what does that mean? What am I doing?
You're taking 6 times n.
Yeah, 6 times n and 6 times 2. 6 times n gives me 6n plus 12. Good. And then we'll just bring everything else down. So now I have 6n plus 12 equals 24.
So the minus 12.
Yeah, minus 12. Okay.
12 cancels.
Good. 12s cancel.
6n
6n
equals 12.
equals 12.
Divide by 6.
Good. Divide by 6 on both sides. Beautiful. N equals 2. Amazing. Okay, so that is numbers 1 through 4 on that first page. And then you'll notice number 5 is optional. This is a bonus question. On your actual quiz, you will have a very similar bonus question. So I'm just going to show you what I might expect if you decide to do the bonus. It says, find the mistake in the student's work and correct it. So you are the teacher on this one. You're looking at this problem. It says 40 equals 3n plus 4. And the student solved the problem. So let's see if we can identify the mistake. So it looks like the first thing this student did is they subtracted 4 from both sides. Is that the right thing to do?
Yes.
It is. Good. So check mark. We don't need to do anything there. So they canceled the 4s and brought down 3n. 40 minus 4, 36. Is that all correct so far?
Yes.
Okay, great. Then it looks like the student multiplied by 3 on both sides. Ooh.
Just divide.
Ah, good catch. So this is incorrect. To correct the student's work, everyone has different grading methods, but I would cross off the step they did wrong. And if they did that wrong, their answer's got to be wrong too, right? Now to correct it, what could we write to say how to correct it?
3 divided by 3.
Yeah, we should divide by 3 instead. Now you also need to tell them what the right answer is. 12, because then we would have 36 divided by 3, which would give us 12. So, let's see, we could say 12 equals n, or n equals 12. Something like this would be just fine. You could also rewrite the problem and solve it yourself off to the side, and I would consider that a good enough correction. But just make sure that you are crossing off whatever part they did incorrectly, and you'll get some bonus points. So, any questions about that? Alrighty. Well, let's go ahead to the next page then. And now we're looking at inequalities. So let's do some of these together. Now remember, when we're solving inequalities, it's the exact same process as solving an equation. The only thing that is different is the graphing and the sign flipping, if we need to flip. When do we need to flip our sign?
If we are multiplying or dividing by a negative number.
Yes. Now, make sure also that we're talking about if we're multiplying or dividing by a negative number on the variable too. Yes. So let's wait till maybe we get to a problem that we need to flip it, and then we'll make some sort of note to help us remember. Let's see. Let's start with number 6. N divided by 4 plus 6 is less than negative 2. Yeah, let's start by subtracting 6. And my 6's will cancel. Good, we'll bring that down. N divided by 4. Bring down my less than symbol and negative 8. Good. All right. Perfect. Now we're going to multiply by 4 on both sides. My 4's will cancel. N is less than negative, what'd you say? 32. Okay. All right, N is less than negative 32. So we have our answer. We circled it. How do I graph it? Negative 32. Circle it. Don't shade it. Perfect. And to the left. Because it's less than. Left. Just shade in the direction the arrow is pointing. Perfect. Perfect. Okay. Any questions on number 6?
I got positive 32.
Positive 32. So let's see. Did you get this step correct where it was N divided by 4 is less than negative 8? Or did you write positive 8? Positive 8. That's where we messed up. So we started with negative 2 and then we subtracted 6. And negative 2 minus 6 is negative 8. So that will change your answer just a little bit. Because when we do a negative times a positive, we get a negative answer. Does that make sense? Okay, good. Okay, let's look at number 7. What do we do here?
Minus 4.
Yes, let's subtract 4 from both sides.
4's cancel out.
Good, 4's cancel.
Bring down 3, negative 3 in.
Negative 3n greater than or equal to 9. Divide by negative 3. Uh-oh, what are we thinking about here? What did we just do? We just divided by negative 3, which means our sign has to change. We need to change it from greater than or equal to less than or equal to. Now, what happens to my negative 3's? They cancel, and I'm left with n is less than or equal to? Good. 9 divided by negative 3 is negative 3. That is our answer. So, if we divide by a negative on both sides or multiply by a negative on both sides, that tells you to flip the sign. So let's make a little note of that. Let's see. When we multiply or divide by a negative number, I'm going to say on the variable, because what really happened and why we had to flip the sign is that we started with negative n and now it's positive n. If negative n is greater than 3, positive n is greater or is less than negative 3. So we need to flip the sign when our variable changes. So when we multiply or divide by a negative number on the variable, flip the symbol or flip the sign. Okay. So we have our answer. N is less than or equal to negative 3. So how do we graph it?
-3,
Negative 3 on the line.
circle it,
Circle it.
color it in,
Color it in. Why do we color it in this time but we didn't last time?
because it's less than or equal to.
Yeah.
3.
Yes. On number 6 we had less than. Number 7 is less than or equal to that little line under the symbol. When you see that line, we color the circle in. Shade to the left. Good. Very nice. Okay. Pretty good. Any questions on number 7? I'm going to start scooching it up a little. I'll leave it so that we can still kind of see it. And let's start peeking at number 8. So, number 8, yes, we could distribute to start. Perfect. So 3n minus 6 greater than 30. And what do I do next? Yes, add 6 to both sides. Mm-hmm. 3n greater than 36. Perfect. Yes. And we get n is greater than 12. Perfect. Perfect, perfect. All right.
Put 12 down there.
Put 12 down there.
Leave it open.
Yes, we'll leave that circle open.
And shade to the right.
Shade to the right. Now, guys, I want to emphasize, whenever you do your graphs, make it very obvious whether your circle is open or closed. I've had a few students in the past do something like this where I could tell they weren't sure, and they were like, they'd do something like that. So it's like, maybe it's colored in, maybe it's not. You know, don't do that, okay? Make a confident error. You can make corrections if you make a mistake, okay? It's not the end of the world. Make it obvious so that I know what your answer is. Okay. Any questions on number 8? All right. Number 9. What's weird about number 9?
Variables on the right.
Oh, my variable's on the right side. It's over here instead of the left. So, we're going to have to do something weird at the end here. Let's go ahead and solve this first. What should I do?
Add 8 to both sides.
Yeah, let's add 8 to both sides. Good, my 8s will cancel. 20 less than 4n.
You divide by 4.
Perfect, divide by 4.
4 cancels.
Mm-hmm.
5 is less than n.
Perfect. 5 is less than n. Now, be careful. What do I need to do here? I'm going to flip the whole thing. Because why?
Because you need your n on the right, on the left side.
Yes. I am graphing n. I'm graphing all the values of n. So I need n to be written first. So if I switch these and write n first in 5 seconds, what do I do with the symbol? The symbol needs to get flipped as well. And a great way to remember, don't even think about it just being a rule having to flip it. I like to think of the alligator way, okay? Here's my really scary alligator, and he is eating the letter N. When I change the direction or change the order of my letters and numbers, that alligator still likes the letter N. He should still be eating it, okay? So, silly, but it's the way I remember, and it works. So this is your answer. That is your answer. Okay.
5 down.
Let's put the 5 down.
Bullet.
Circle.
Shade to the right.
Shade to the right for greater than. Perfect. Perfect, perfect. Okay. Questions on number 9? Okay. Let's go ahead and peek at number 10. On Thursday, we started talking about compound inequalities. The reason we didn't spend a ton of time on it is because it's the same thing we've been doing. The only difference is you are graphing 2 inequalities on the same line. That's the only extra step we do here. We will solve these one at a time and then decide where they go. So, for number 10, let's start with our first one. Negative 2n is greater than 12. Divide by negative 2. There should be an alarm going off in your brain. What just happened? We divided by a negative. We flip the sign. So, yes, my 2's will cancel. When I bring my sign down, instead of greater than, it is less than. N is less than negative 6. So that is one part of my inequality. Yep, and then over here we just do what we need to solve it. We'll multiply by 3 on both sides. N is greater than 54. Okay. So I have my 2 answers. Yes, why do I put negative 6 first instead of 54? Because it's less than, it's smaller. You see the number line goes from the smallest numbers to the biggest. Smallest comes first. So we'll write negative 6 and then 54 on the second tick mark. Circle both. Perfect. So because this is an OR inequality and because of the direction our arrows are facing, we're going to shade outside like this. We have N is less than 6. Less, it points outwards that way. And it's greater than 54. Our arrow is pointing this way. And this would be our answer. Just like that. So, if you were not here Thursday and you're just seeing this for the first time, it's not much different than what we've been doing. It's just one extra step. Okay. Any questions about that one? All right. I'll wait just a minute before I flip to the next page. I see a few of us still writing. Yeah, almost done. Pretty nice. Okay, I'm gonna go ahead and move to the next page unless does anyone still need this? Okay. Number 11, this is the last required question. Number 12 is optional, it's bonus. So, we have another compound inequality. 5 plus n divided by 3 is greater than or equal to negative 2, and negative 3 plus 4n is less than 21. What should I do first on this?
5 on each side.
Good. We have a plus 5. Let's do minus 5. My 5s will cancel. So I have n over 3. Good. Negative 21. Where'd you get that? Oh, that's okay. Negative 7. You're just a step ahead of us. That's okay. All right. So we've got that. Perfect. Multiply by 3 on both sides. 3's cancel. Beautiful. N is greater than or equal to negative 21. So we've done the first one. Yep. Well, let's wait. Just in case. This probably will be the number that comes first. But we want to make sure that we don't get an even smaller negative number. Just in case. You never know. Yeah, so let's add 3 to both sides. Perfect. 4n is less than 24. Good. We'll divide by 4. N is less than 6. So you are correct. Negative 21 goes down first because it is the smaller number. And yeah, we'll circle it because it is greater than or equal to. We color that circle in. Yes, and our 6 is just less than. We don't need to color the circle in. And we shade in the middle. You are correct. And inequalities point towards each other. N is greater than or equal to negative 21. That greater than is pointing this way. And that less than is pointing that way. Pointing at each other, we shade in the middle. All right. And the very last thing is another optional bonus. Again, you don't have to do bonus ever, but it won't hurt you even if you get it wrong. It will only help. Before we start that, though, do we have any questions about what just happened? Okay. Does anyone still need to see this? Can I move it? I'm going to move it. Okay. Here's another student work example that we're going to try and correct. So, this student solved, or so they tried to, a compound inequality.
The top first, the first is right, but
Okay, let's...
they divided and you're supposed to multiply.
Ah, you're right. So they added 2 to both sides. That was correct. They brought everything down. N divided by 3. To get rid of divided by 3, they divided by 3. Nope. What should they have done? They should have multiplied by 3. Multiply by 3. And what would that change their answer to? 15. So it should have been N is less than 15. Okay. So we've corrected this one. Let's check the other side. Minus 2, that's right. 3n to 9, that's right. That all look right?
Yes.
That looks right to me. Okay, so let's see. Oh, I'm actually gonna have you guys mark something off. I must have copied this down wrong. This is not an or inequality. This is an and. That's my mistake, not the students. Okay, so we fixed this. We need to fix the graph now. So, what's wrong with the graph?
You need to flip the numbers.
Yeah,
It needs to be on the left side.
if they had gotten 1.67, if that was correct, it should have came first. But now it's 15, not 1.67. So let's see. If my answers are 15 and 3, is 3 smaller? Does it come first?
No, 15 because it's still less than, isn't it?
So n is less than 15, meaning n can be any number smaller than 15. 15 is just the point on the number line that we're referencing. So we're thinking about which number comes first on the number line, 3 or 15? 3. So 3 is actually in the right spot, but what needs to change? Yeah, this is not the right number. We're going to put 15 instead. Now, is the shading okay?
Yes.
Yeah, the shading's actually okay. If I had written and instead of or, that's my fault. So, these are the 2 corrections we made. Looks good. Okay, guys. That's your practice quiz. So, it is 1:32. We're not even all the way through period 3. But I want to kind of talk to you guys about your options for today. If you feel confident and good about this, you could take the quiz today if you want. You got the whole rest of until 3:30 to do it. That's like 2 full hours. If you want to try to take it, go right ahead. You can make corrections today. Tomorrow is the day that I will actually give the quiz. It's like the scheduled day that we'll be taking it. But there's nothing wrong with giving it a go today and making corrections tomorrow instead, maybe. Or maybe you do really well today. Or maybe you don't feel confident. That's okay too. The rest of class is going to be used for your practice, study time. I'm here to help if you need it. Yeah, that's what we're doing today. So we've finished our practice quiz. If anyone wants to do the quiz, that's an option. If you are ready to just go home and you want to come back and do it tomorrow, that's great too. You're welcome to leave. It's really up to you guys. So that is what we are doing. And I'll write down kind of the options for everybody so that we know what we're supposed to be doing. So option 1, go home. You can leave. Option 2, take the quiz early. Option 3 is you can use this as study time. So these are your options for the remainder of our class time. I am just going to be available to help if you need it. We'll treat the rest of class like office hours, like we do on Fridays. I'm going to be up here working on my things, putting grades in. Feel free to come up and ask me questions if you need. That's what I'm here for. So I'm going to go ahead and end our recording. That's it today. Choose any of the options. Up to you.